So I am taking lambda expression for it. Run lambda expression I am taking. One lambda expression I go with registration logic, and one more I'll go with run lambda. One lambda expression I go with registration logic, and one more I'll go with okay. In this registration logic, you know lambda already. We write parameter list. Here parameter not available. I'm taking the body here. Here we write some registration logic we are going to write. Here we write the body. Login logic. So they are presented in the form of lambdas. So let me write this program anyway. So I'll take one more application here. So application user app 2 for demo purpose. I'll take two packages. One package again I will take. Test package I will take. One more package I'll take. And access I'll take. Under test I'll take. No need of test package. Demo main I will take. So directly we are writing lambda expression here. Whenever you want write lambda expression for the method of run, runnable R1 is equal to lambda. This is 1 lambda. Runnable R2. This is 1 lambda. Here 1 for loop. Int I is equal to 1. I less than or equal to 5. I plus plus. This is end of loop. Here we write try, catch, exception E dot print stack trace. So system dot out dot println here RAM registration process. We display the time as if like above program. New date. Java dot end of loop. Int I is equal to 1, I less than or equal to 5, I plus plus. Fine. Catch. Exception E dot print stack trace. So system dot out dot println. So LX login process. New date. Here thread dot sleep 2000 milliseconds. Thread dot sleep 2000 milliseconds. So run method is only one method available from Lambda. Sorry, from your runnable interface. So whenever we want to execute this run method, these lambdas are the bodies constructed for run method. Whenever you want to execute run method, we need start method. But the start method is not available from runnable. You can observe this. Start method is not available from runnable. So whenever you want to start method, we need thread class. Java p java dot lang dot thread class. In that thread class only start method is there. So what we do now? So here we create object for threads, thread class. Thread T1 is equal to new thread. I'm creating one object. Thread T2 is equal to new thread. I'm creating one object. So thread T1 is equal to new thread and thread T2 is equal to new thread. But we should link that objects now. This runnable and thread. So we pass R1 as parameter here and R2 as parameter here. The meaning, this thread object is holding the reference of runnable. This thread object is holding the reference of runnable 2. Now we can call T1 dot start, T2 dot start. You can call it. So if we run it, the two are executed simultaneously, they can run. Two are executed simultaneously. So first model, we can create a thread by using thread class, and second model, we can create a thread by using runnable interface with lambdas. Here I'll make a statement. In the process of creating threads, we must construct LAMBDA, lambda expressions for run, for run method of runnable interface. Runnable interface. Create thread class objects while object creation pass runnable implemented runnable implemented object references as parameters. Here implemented means lambda expression is the implementation. Which means, for clarity purpose, which means thread class object will hold the reference of implemented object of runnable interface. How this implemented object will come means using lambdas. The meaning. Same. Execute run method. Execute run method using start method. So this is called fundamental for you. So thread definition, program definition, application definition, how to create threads by using run method and runnable. So these are the fundamentals, we call it. This is called fundamentals. This is the basic thing. So this is the part one. We had it. So I kept a live streaming in YouTube also for you. Who are unable to register and join, they are available in streaming anyway. Nana. So very add one more concept known as synchronization, you can say. For that, I'll 5 minutes, I'll give a break here. So let us continue. We had a concept known as synchronization. The process of executing multiple threads, one after the other. The process of executing multiple threads, one after the other, is known as synchronization, you can say. Synchronization process can be performed in two ways. One, mutual exclusion process. Thread communication process, you can say. Mutual exclusion process, or you can say thread communication process, you can say. The process of locking the programming resources. Programming resources means class, method, class, object, and method. According to this mutual exclusion process, programming resources, you can say class, object, and method. The process of locking the programming resources and ordering threads for execution is known as mutual exclusion process, you can say. This mutual exclusion process can be done in three ways. You can synchronized block, synchronized method, static synchronization, you can say. Synchronized block. The process the set of statements which are declared with synchronized keyword. The set of statements which are declared with synchronized keyword is known as synchronized block. The syntax is synchronized here reference variable. Here some statements we are going to statements. This synchronized block is used to apply the lock on. The synchronized block is used to apply the lock on the object, and which is known as object locking process. You can say object locking process, you can say. So like this. Suppose one printer is there here. You take one printer class example. Here one method is there. Void some print and int and string name. This print method is going to perform the print option. Here print process is there. So print. So that is one class actually. Suppose here one user is there, here one user is there. Two users. This user one always I'll take Ram again. This user two, I'll take Alex. Now both want to perform print option. Means user one want to perform print process. User two want to perform print process. So both are trying to use the same resource here. That's called shared resource. In that process, they have to run one after the other. Then only locks will come. It's called synchronization anyway. Let us make that printer object available to both. Let us make that printer object available to both like this. I'll take one program again. User some synchronization. I am taking one project. Application. Synchronization I am taking. I'll take one package here. Test I am taking always, you know. I'll take one more package here. M-Access I am taking. Under M-Access, sorry, under test, I'll take one printer I will take. I'll take one class known as printer. I will take. This is normal subclass. Normal subclass means which is not implemented, which is not extended. This is one normal subclass, not related to any component. It's called normal subclass. Normal subclass. You can see. So here we have a method known as print. Public void some print into some n. String some name. Here, how many prints means some int I is equal to 1, I less than or equal to n, I plus plus. Some n prints I want. So here, system dot out dot print print for the name. We are printing for whom? The name I am printing. Thread dot sleep. For output purpose, we are giving some delay time there. Like this, I took one class here and class is having one method known as print. So based on your n value, the loop will run and gives the prints to you. Now you have to create object for printer. In the main class, I am creating object for printer. Under M-Access here. Demo main I'm taking. Here import test dot printer. I'm creating object for printer P is equal to new printer I'm creating. So I must create users. One is user 1 RAM, user 2 LX. So whenever you want to create this user 1, user 2, just now models are available to you. I'll take runnable. I'll take runnable. Interface I will take, which is providing one abstract method known as run. So we are writing lambda expression for this run. There's a logic available. We are writing lambdas for it. So we are writing implementations in the form of lambda. Implementations in the form of lambda. So runnable R1 is equal to lambda. I am writing. This is one lambda. Runnable R2 is equal to, this is one more implement. So this is for user 1, Alex. This is for user 2, Alex. Now these two are run methods anyway. Here P is there. You can call it P dot print. I want 5 prints. My name is Ram. So this method is calling this print method. Here P dot print. I want 5 prints. My name is Alex. So both are calling the same method. Ram is calling the same method print. Alex is calling the same method print. You know already. If you want to run like a threading flower, start method mandatory. So thread T1 is equal to new thread of R1. Thread T2 is equal to new thread of R. T1 dot start. T2 dot start. So here locks are not available. When the locks are not available here, when the locks are not available, this print method is available for both. Both will use that print method. You can see the output. Now one print, this is print actually, one print for Alex, one print for Ram. So how can a printer print for both users at a time? Not possible. You can take printers available in the real-time scenario. They'll take the prints one after the other only. So let us make synchronization here. You must not do simultaneously, you must not do. You must do one after the other you have to do. For that process, whenever you want to do one after the other, then you have to lock it. So what you are going to lock? Sir, we are going to lock the object we are going to lock. So like this, synchronized of P. Synchronized of P. Synchronized of P. Suppose the access came to RAM means it will lock the object and run the method. When the lock is applied by the RAM, the method is not available to Alex. The method has to wait for that object. Sorry. The Alex has to wait until the RAM releases the object. So we are locking the object. So RAM executes first because the lock is applied on the object. Of the RAM execution completed, then Alex will be executed. You can see the output one after the other. The output is one after the other. So how it happens, sir, means we applied the lock on the object. You can see here. RAM applied the lock here. When the control comes to the RAM, he locked the object. P is an object. When he locked the object, automatically, what are the instance methods available within that object? They'll be locked. And the methods are available to one user at a time. So only RAM is using that print method. Alex cannot use it because he not locked that object. That is one kind of synchronization. That is model 1. It's called synchronized block. So this is object locking process. So here we took one application anyway. application synchronization. Under test, we took printer, we taken. Under M axis, we took demo main dot job. If we apply the lock on the object, if any multiple instance method available within the object, all that methods will be locked. Sir, I don't want to lock all the methods. I don't want to lock all the methods. I want to lock only individual instance method I want to lock. So whenever we want to lock individual instance method, we had an option known as synchronized method option is there. Synchronized method. Yeah. The process of declaring instance method with synchronized keyword. The process of declaring instance method with synchronized keyword is known as synchronized method. The process of declaring instance method with synchronized keyword is known as synchronized method. In this process, the lock is applied on individual instance method and the method is available to one user at a time. The structure, synchronized keyword will be there. Return type will be there. Method name will be there. Parameter list will be there. Here, method body. Just declaring one instance method with a synchronized keyword. We call it as synchronized. Static synchronization. The process of declaring static method with synchronized keyword is known as static synchronization process. In this process, the lock is applied on the class and which is also known as class locking process. Okay. Structure, synchronized static return type, method name, parameter list. Method body. So thread communication process. The process of establishing communication between threads. The process of establishing communication between threads using the following methods. Following methods from java.lang.object class is known as thread communication process. Okay. The process of establishing communication between threads using the following methods from java.lang.object class is known as thread communication process. One is wait method, one is notify method, and one is notify all. So thread communications, I'm going to introduce in the coming part 2 of your multi-threading. I'm going to introduce in the second part. In that second part, I introduce thread communications with executor framework. I'm going to bring it. So this is for today. Call it as fundamentals of multi-threading introductions to all. In the coming batches, I'm going to introduce Thank you very much for today.